Yeah, make the sine x dx be the du, right? Good idea. I'll make it minus du because we want u equal to cosine. Right? And so that would make this 1 minus u squared squared. So just to put that into, we have minus the integral of 1 minus u squared times 1 minus u squared du. I brought that minus out front just to keep me out of trouble. And multiply, what do you got? U to the fourth minus 2u squared plus 1. So that's the integral of, minus u to the fourth plus 2u squared minus 1. I mean, you leave the minus out front, whatever you want to do with the minus. I don't know, it's your business. But of course, this is 1 minus 1/5 u to the power 5 plus 2/3. And the integral of 1, nope, not 1, u. Yeah, minus u in this case, but yeah. And then, of course, plus a constant. And then u is cosine, right? So we go, okay, so I mean, it takes a little work, there's a little writing to do here, but honestly, the fifth power is really not that hard. And the same is true, if I did cosine to the fifth, it's kind of the same thing, right? In fact, anytime you have cosine or sine to an odd power, we can use the same essential trick. Just peel off the even part of it, the remaining cosine of x dx or sine of x dx, make the du or the minus du, and kind of go from there. Now, even powers are a pain. All right, I'll just say that for the moment. Maybe I'll come back to it in another class. I want to focus on the easier part for what remains here. I'll just say that, like, to do cosine to the fourth or sine to the fourth, it's kind of a pain. It's, Now, there's also problems that are kind of somewhere in between. Something like this. What if you had integral of like sine cubed x cosine, cosine squared of x dx? I don't know. How would you do something like that? So they're like basically two paths you can go down here. But I usually look at if there's one of the powers is odd, then I'm going to use that to like peel off the du. So I'm going to say, okay, well that's really the integral of sine squared x, cosine squared x, and then I've got my sine of x dx. So I'm going to make that like minus du, because I'm going to let u equal to cosine of x. Do what? Well, we have to, when we make a substitution, we have to change both the dx and the integrand. So I need part of the sines or the cosines to go into the making of the du in these kinds of problems. So that's why. Now, but sine squared is what? It's 1 minus cosine squared, right? Well, that was minus du, right? So, I mean, this is really what? 1 minus u squared times u squared. There's a minus out front. There's a du. And then what? That's u to the fourth minus u squared du. And then, mm-hmm. Mm-hmm. 1/3 u cubed, yeah. And there's no du. We integrate. The du it's part of the integration notation. And once we're done with the integration, we have a function. There shouldn't be a du in the answer. And then we go back to cosine, right? So it's 1/5 cosine to the 5th of x minus 1/3 cosine cubed of x plus a constant. There are some problems where you can kind of go a couple different ways. Here's one of those. You have the integral of sine of x cosine of x dx. And I'll put a 2 out front just to make it really nice. How would you do this integral? How about one way you could do it would be this, right? Say, okay, aha, I'm going to make this my du. I'm going to make sine of x u. If u is sine x, cosine is du. Cosine x dx is du. So that's really the integral of 2u du, which is 2 over 2, well, 2u squared over 2 plus a constant. In other words, it's sine squared x plus a constant. That's one way. Another way to do this is by trigonometry. See, 2 sine cosine is the sine of 2x. That's a trig entity. And so this is just minus 1/2 cosine of 2x plus a constant. The half because we're integrating over 2x. And so we make a u equals 2x, which brings down a half. Wait a minute, how are those the same answer, right? Look at that. How can these be the same answer? What is sine squared x equal to? It's 1/2 of 1 minus the cosine of 2x, right? So in fact, that sine squared has a hidden minus 1/2 cosine 2x inside of it. Now the underlined and the double underlined expressions, they're not equal. But they're the same answer. How can I say such a thing? What kind of, mathematical voodoo am I using? How can I say that they're not equal, but they're the same? What I mean by that is that the derivative of this and the derivative of that are both the same function. However, this constant and that constant, they're not equal. Like technically I should use like c bar for this other one. See, because, they differ by like a half or something like that. But anyway, time's up, so enjoy the rest of your honors day. Any of you going to the festivities? No? That is why I did not stop class at 12:15, my bad. I just figured. You guys paid for a full semester, you should get a full semester, right?